force at the edge. In case they give us the forces as this on the edge, what are we going to have? In case the forces are at the edge, you will say force total is equals to force 1 equals to force 2 equals to force 3. Meaning the force will be the same in this part, which will still be that force. You agree with that? That is in case they give you two forces on the edge. Either they are extending or they are trying to compress. No? You have this. This is when they are placed in parallel. In series. Now, please let's take note that this stress is equal to force all over area. Stress is equal to force all over area. Meaning, the stress in 1 will be equal to force in 1 all over area of 1. You agree, no? Stress in 2 will be force in 2 all over area of 2, and stress in 3 will be force of 3 over 1. Now, please let's take also note that the change in length will be equal to what? Please remind me, is this, what is it? Something like this, no? Do you agree, no? Stress times L all over E. Alright. Now, this stress, since the stress is equal to force, which we can also call P, that's why we say force times L all over area times E. Now, please let's take note of the whole of chapter 2. Not the whole of chapter 2. The first section of chapter 2 will be dealing only with these three guys here. Only with these quotients here, or these formulas. Now, these guys will be placed either in series or in parallel. As this case where they are placed in series, we have this kind of quotient or this set of formulas. Please take note that if they are in series, the total length is equal to length 1 plus length 2 plus length 3. Right? And the force on the extremity is equal to force 1 plus equal to force 2 and stuff. We have that. And we have our two equations. Alright. Now, we come here. If they are placed in parallel as something like this. Now, this is copper. Alright? We're trying to look at it as if it's a circle. They did the section there, huh? Did you all do physics? Drawing too? Yeah. Alright? Meaning there is the big one, and a small one inside. Do you agree? Now we're trying to cut it in the middle. Now let's assume that at the edge of this thing here, there is what? They place them together with some component, alright? Which is this guy here. Now they come and apply a certain force here, which we call a force total. Now, in case they are in parallels like this, the change in length, you will see that if this thing here goes down, the same length that this one here will take will be the same length that this one also will take. Do you agree with that? If it's compressing, the same compression that this one here will take will be the same compression there. So therefore we'll say the total change in length will be equal to change in length 1 equal to change in length 2 equal to change in length 3 if we have 3 things. Do you agree with that? No? Yep. Now, what is this guy? The force. Now the F total, the force total in this guy here will be distributed in the components. It will be in this guy, in this one, and in the last one. So force total will now be equal to force 1 plus force 2 plus force 3. Do you agree with that? Huh? Now, please let's take note that whenever you have any case, the portion which has change in length 1 equal to change in length 2 equal to change in length 3. That's what will be the component which will give you the relationship or the relation between the stresses. Alright? As in this case, we're dealing with the forces. They said force 1 equals to force 2 equals to force 3. Do you agree with that? in this case, you will come and say, meaning F1, if F1 is equal to F2, meaning what? You come here on the stress, you take this, you send it the other side, you say stress 1 times area 1 equals to stress 2 times area 2. As I said, the guy which is equal, that's what will give you the relation between the two components or three components. Do you agree with that? Meaning, if you are here, the guy which are equal, that's what will give you the relation between the components. And most of the time, look at the stresses. Do you agree with that? Now here, if I say that the lengths are the same, meaning if change in length 1 equals to change in length 2, meaning I come on my change in length is this guy. Stress 1 times L1 all over E1 equals to stress 2 times L2 all over E2. It is on this guy here that I will get the relation of the two stresses. Okay with that now? So you get the relation on the parts which are equal. Here, it was the force, I get the relation from there. Here, it's the length, I get the relation from there. That's actually the small game that we'll be playing on this thing. All right. Now let's